Hi everybody, this is Bonnie Seaman. I just want to let you guys know we're going to be starting in a couple minutes. All right. Hi everybody and welcome to today's webinar, Stop Appliance Sprawl and Traffic Backhauling. Just a couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right side of your screen, and we'll go over the questions after the webinar. And of course, there will also be a recording of this webcast available within a couple of days. Now, it's my pleasure to introduce VP of Marketing at Cato Networks. Ishai has over 25 years of experience in defining and deploying enterprise IT software solutions in the areas of security, storage, business continuity, and mobile computing.
Hello, everybody. Okay, hopefully you can all see my screen now. Okay, so welcome to our webinar today, and I will be presenting our views of the topic of today, which is appliance sprawl and traffic backhauling, and how we can address them and the challenges they create for our businesses. First, I'll start with asking you a question just to get acquainted with how you relate to this topic.
All right, our first question is, what do you use to connect your branches? I'll give you guys a couple of minutes to click and choose an answer. All right, we'll do a couple more seconds here. All right, Ishai, I think we're ready to get this started.
Okay, so as we can see here, it's pretty much split. We're seeing this consistently in surveys we're doing and customers we're talking to. Everybody chooses either one of these options. So a little bit about Cato before we get started. We were founded by two veterans, Shlomo Kramer, the co-founder of Checkpoint. He's a network security expert, basically one of the people that built the first commercial firewall. And Gur Schatz, our CTO, he's a networking expert, global connectivity from his days at Incapsula. He created one of the first anti-DDoS companies. And between them, what the company is trying to achieve is to converge these two domains, networking and security, in the cloud in order to address some of the problems we will be talking about today. So what's the issue with this Backhaul and Sprawl, appliance sprawl thing? The challenge is that it's fundamentally a very tough trade-off. It's basically two different network and security architectures that customers choose when they deploy their networks. Backhauling means that you put a network security stack in your headquarters or in your data center, and you're using typically MPLS links to connect all your branches to this central location, which becomes the main exit point to the internet. So instead of getting out at the branch, you send your traffic to your data center, and from there you get to the internet. Appliance sprawl is kind of the opposite approach. What you do is you put a network security stack in every location, and you basically interconnect all your locations by creating tunnels between those firewalls, and also use those firewalls to secure traffic to the internet. So the first option is to try and backhaul all the traffic, the internet traffic. The other option is to send the internet traffic directly at the branch and build the wide area network by interconnecting those different network security components. Why is it a tough trade-off? Each one of these options have substantial challenges associated with it. So if you think about the MPLS backhaul, this is a network design that is, first of all, very expensive, as most customers know, and it was built to interconnect fixed locations. And what we're having today is that there is a vast increase of internet traffic, which security and optimization of that traffic in an MPLS environment was always an afterthought. Why? Because internet traffic never amounted to much of the overall traffic of enterprises, so the penalty you pay by backhauling all the traffic to a central location and sending it to the internet wasn't that substantial, both on the terms of capacity of the links, as well as the user experience problem, this added latency, also known as the trombone effect. What is happening today is that the usage of cloud and mobile traffic is exploding and putting a lot of pressure on those networks and their design. So that's the challenge with the MPLS backhaul. Appliance sprawl has a different set of challenges. With appliances in every location, you have to buy them, deploy them, refresh them. From time to time, you have to upgrade them for capacity purposes or patch their software, and you have to do it repeatedly at every location. So the more distributed you are, the bigger the challenge. And the number of people you have to address that didn't grow or is fixed, so they have to run around just to keep the infrastructure up and running. So if we summarize that, you either have a bad user experience with added latency and wasted resources on the MPLS backhaul side, or you basically have an ever-increasing complexity as your business expands, you add more locations, you have to keep your infrastructure up to date, and you simply don't have either the people or the money to do it. So this is kind of the challenge, but you have to be somewhere, so customers choose either one. So we're going to ask now another question about the challenges of maintaining your wide area network.
All right, so for the second question, we have, what is the biggest challenge you need to address in your WAN? And remember, you guys can mark more than one answer on this question. You can start now. All right, we'll give it a couple more seconds. Okay, let's share the results.
Okay, so when we look at this, again, we see kind of pretty good representation of all the options. The cost of MPLS and capacity constraint are related. Typically, customers use a limited amount of reduce cost, which is, of course, on the network. They want to have direct and secure internet access. Again, lack of a network security stack in MPLS networks creates a challenge in that regard. High latency is typical for a global wide area network environment, especially when you use multi-site VPNs. So your traffic is traveling over the open internet where there is no guarantee of SLA or latency. And finally, just managing all this infrastructure, distributed infrastructure, is very difficult. So, pretty good representation of all the different challenges that we highlighted. So, what do we want? What do we want? We basically want these problems to go away. We don't want appliances, but we do want to have security everywhere. We don't want to backhaul our internet traffic, but we also need it secure and optimized. And this is the order. So what we ultimately want is that we want to make network and security simple and affordable. That's essentially the goal. And basically, we want to mitigate all these issues that I've discussed kind of in one shot. And that's a tall order. So this is where I'm going to describe how network plus security as a service, which is what Cato is offering, is going after these set of issues in a single platform. How do we do it? Basically, in order to fix this problem, we believe that we have to first fix the network topology challenges associated with the different elements, and only can then we address the security challenges. So first, we connect all the different network elements, the headquarters, the data centers, the branches, the cloud infrastructure, the mobile users, into a simple, single network in the cloud. This network, this backbone, is carrying both wide area network and internet traffic, which means that it consolidates the organizational traffic in the cloud. And I'm talking about the traffic between the elements and the elements of the internet, not the local area network traffic. Once we have the traffic consolidated, we can now secure it. So we built a set of cloud-based network security services directly into the network fabric. So we basically can process and secure and monitor all the traffic that flows through the backbone. And finally, once we have the traffic and the security consolidated, we can enforce a policy across all elements. So instead of using point solutions for mobile and cloud and physical infrastructure, we can actually use one policy to govern all traffic. How does it work? So let's start with a network pillar. What Cato had done is build a global network of points of presence. Those points of presence are basically standard servers running our own software. We have no appliances, no routers. Everything is implemented in software. At the network layer, these POPs are handling routing, reliability of traffic, so implementing different algorithms to minimize packet loss, different optimization by selecting the best route between every 2 points, and of course, encrypting all the traffic as it traverses the backbone. The backbone itself is provided by Tier 1 carriers. They interconnect our POPs. Telia Sonera and Iberia Networks is the one we currently use. And when we use a carrier like that, we can actually provide SLA-backed latency between every 2 locations. So the customers are ensured that they will get consistent latency and will not be subject to the whims of the public internet, which is what's causing this high latency between locations that you have indicated in the earlier poll. How do you plug into that backbone? So we basically create a tunnel overlay that connects the different elements into the backbone. There are multiple ways to achieve that. One option is to connect an existing firewall in a headquarter or a data center using an IPsec tunnel to the nearest point of presence. If you look at a branch that did not have or does not have a firewall, we provide a small tunneling device called the Cato socket. It takes all the traffic from that location and simply forwards it to the nearest POP. It doesn't enforce any policies or any security, so it basically it's a zero maintenance, zero touch device, but it does move the traffic to the nearest POP. We have a virtual version of that for cloud data centers that connects Amazon AWS, Azure, and move all the traffic from servers hosted in these environments into the nearest POP. And finally, we have a software client, the Cato client, that you put on endpoints, PC, Mac, iOS, and Android, and it forwards all the traffic from that device to the nearest POP to where the user is located, and then the traffic from that user goes across the backbone and either gets into a data center resource, either in the cloud or in the physical data center, or goes to the internet. The last piece of this is that we are able, with the Cato socket, to manage both an MPLS link and an internet link, and basically do a policy-based routing between those resources. So this is the network backbone. This is how we consolidate all the traffic, we route, optimize, and improve the quality of that traffic. The next pillar is our security stack. So again, this security and network and security stack is fully integrated. It runs within our POP, and it's all implemented in software. What are we providing as a security service? We're providing a next generation firewall that is fully application aware, and a URL filtering solution. This is kind of our core set of services. And those are built directly into the network and are available everywhere. We are maintaining those services, we scale them, and we're updating them automatically. Customers do not have to be concerned with sizing. Once you deploy the socket or an IPsec tunnel, the traffic that you're sending to the POP will handle the security services back. So you don't have to deal with this phenomena that device runs out of capacity when you activate additional features. We are continuously rolling out additional capabilities, cloud access control, network forensics, infection prevention, extrusion prevention, that we're adding to the platform. So this is the security layer, and it's all, as I mentioned, fully integrated with the network stack. The last piece is the policy engine. So for the policy engine, we are able to enforce a unified policy across all users, locations, and data. It can be as granular as you want, but you can also enforce a policy across the organization. So for example, you can enforce a social media access policy within a specific time, and it will apply to users, both mobile, in fixed locations, cloud, etc. There is also a great opportunity here to consume this as a managed service, with our partners providing managed services around the policy, monitoring, events, etc. What you don't have to deal with here is the friction between the service provider and the need to touch physical equipment within the customer environment, which is always getting in the way, increasing cost, complexity, etc., and the overall quality of service. So these are the three elements of Cato. And I want to talk now about two case studies of how customers used this platform to achieve real tangible results. So let's talk about the first one, UMHS. This is a healthcare provider. It's a regional provider in North Carolina, and it has multiple sites, roughly 11 sites. And what's happening in this network is that half of these sites are using firewalls, UTM firewalls, to create a full site mesh, and another subset of the site is using MPLS connectivity. The customer has done this because they have to save money, so they chose to use the firewalls instead of deploying MPLS to all of their connections. They also have several hundreds mobile users that are connected to the data centers as they provide community-based health services. The challenge there was the complexity of managing a distributed environment with a very low number of people, IT people, and the need to refresh the hardware. So what did we do here? Cato provided a cloud-based secure network. So we connected all the sites to the Cato cloud with Cato sockets. We created a cloud-based full mesh for those sites and integrated all the mobile users with Cato clients. And we provided secure internet access for all sites and users. They previously did not activate internet security capabilities on these UTMs. And what the customer is doing is, once their MPLS contract expires next year, the plan is to move essentially all the other sites into this network and achieve full coverage. What you can see here is that there is a potential to do gradual deployment with Cato. So the customer has a legacy MPLS network running side by side with a Cato-based network where security is provided across all sites by Cato. So this is one example, and in this case, the customer has achieved appliance elimination. He basically eliminated the appliance sprawl and consolidated all their networking and security into our cloud. The next example is much more complex, it's just bigger. So this is a global manufacturer. It has 36 locations. As you can see from the diagram on the right, they are concentrated in the US, Europe, and the Middle East. The customer legacy wide area network was backhauling all site traffic into an SAP instance hosted in the customer data center in the Middle East. And the customer made a strategic decision to migrate to an SAP HANA Enterprise Cloud that is hosted in Germany by SAP. So the whole one backhaul was no longer viable. So the customer came to us, and what we basically did is we connected all of their locations into the Cato cloud, of course, across multiple points of presence, depending on where the sites are located. We connected physical locations. Each one of these locations had a checkpoint firewall, so the connectivity mode was to use an IPsec tunnel to connect to the Cato cloud. We also connected several cloud data centers, Azure data center, AWS data center, and also the SAP HANA instance into the Cato cloud. And now the customer has an optimized SLA-backed latency to SAP HANA from anywhere in the world. The customer went further and eliminated 4 firewalls in 4 locations and replaced them with Cato socket. The plan is to gradually eliminate all these firewalls and replace them with sockets and enforce security through the Cato cloud. So as you can see here, the customer initiated the deployment of Cato to address a global WAN problem, but what they're now able to do is to leverage the platform to get even more efficient and get more cost savings by eliminating a lot of the moving parts of their infrastructure. Okay, so this is the second case study. So let's look now at several demos of Cato in addressing several aspects associated with the technical deployment of a solution like Cato. So let's take the first question. I want to talk about the question that we're getting a lot from customers is what does it take to replace MPLS with internet links? This is worth a whole separate webinar, so I'm going to do just a very high level overview here. So what MPLS provides is guaranteed latency, guaranteed capacity, and a commitment around availability and quality. And if you want to move to an internet-based link, what you want to do is to get to kind of maximize those dimensions with your internet solution, depending on your tolerance for downtime and other variability of the service. So we talked about the middle mile in the previous slide. So you know by now that Cato provides an SLA-backed middle mile. So this is, we have already addressed that. And this is actually an advantage of other solutions in the market, such as most SDN vendors. Their internet leg is not SLA-backed, so they always have to rely on MPLS to guarantee latency. In this case, Cato provides latency in the middle mile. Now, latency in the last mile, which means what would cause a last mile, which is typically a short distance, to increase latency, it typically has to do with capacity and quality, which I'm going to cover next. So when you look at capacity, you have two options to choose from: either a best effort link like an ADSL, where the provider provides you with the maximum bandwidth you can get, typically more download than upload, but you know that in some situations this capacity may not be there. Compare that with a guaranteed symmetric fiber type internet link, which you get a guaranteed capacity. Again, the variability is in the price point. The customer makes the decision based on their business requirements. Finally, and the point I want to touch on here is availability and quality. So one of the things that you want to look at is different techniques and tactics to improve the overall availability and quality of your internet-based connection. So the first one is forward error correction. So basically trying to compensate for packet loss both in the last mile and the middle mile by using this algorithm, which basically means that you send few more packets to compensate for potential loss, and then you can use those extra packets to complete the data that has been lost without requiring retransmission. So essentially, a lot of the problems you're experiencing in applications like VoIP, etc., could be a result of packet loss that requires retransmission, and as a result, you have breaks in your phone calls or in your video conferencing. The second feature or second capability that you can consider is active-active, or using two links concurrently. So you typically are familiar with using two links. One is active and one is backup. Actually using both of them at the same time, so they both back up each other, as well as you can double up your throughput. So another interesting feature that can maximize the availability and quality of your internet-based last mile. And finally, you can use a 4G LTE backup, part of your active-active or as an additional backup option. And as you do that, you actually can get even better coverage in MPLS, because every problem with the physical infrastructure to the site, which could affect MPLS, and even with your SLAs of 4-hour repair, some damage can be just impossible to fix in that window. So an LTE or 4G backup really creates difference here. So let's take a look at how this looks in Cato. So you can see here an example. This is our office. We're connected with two links, two separate providers, two separate ISPs. Those lines that you're seeing here represent the availability of those links, and the gray area represents periods of downtime. So you can actually see that those kind of happen sometimes together, but most of the time just one link is down. You can also see here the packet loss data and how much we are able to recover using FEC that was running on those links. And you can see here on the right side the aggregated view. So you can see there is much less downtime, much less packet loss. So the overall experience the customer is seeing is, of course, much better. So and this is something that you get with getting on the Cato platform as part of our solution. All of these features are available. Let's take a look now how the actual impact of FEC forward error correction. You try to watch a video with or without FEC. Now, what we have done here is that we have simulated packet loss on one of the sites. So there is tools that allow you to show what happens when you have a very high packet loss. Let's take a look. Let's take a look at this demo. So you can see here that in the first site, FEC is off. So right now I'm showing you that in the settings for that particular location, FEC is not activated. On the other hand, in the second site, the configuration shows that FEC is active. Let me show it right here. You can see that active. And now we're going to see how that works in real life. You can see on the top, no FEC, a lot of packet loss, very jittery, very low quality video, and in the bottom, the same level of a packet loss, but we are able to recover those packets. So that was the first demonstration. The second one, so building a full mesh. Building a full mesh between firewalls is really not a trivial task. I won't get into all the details on the right side here, but there are listed 7 steps that you need to do to establish a tunnel, a secure tunnel between 2 locations. If you somehow manage to get into a multi-vendor firewall environment, this gets even more complicated. And this is not such a rare occurrence. If you did M&A in the company, it's very common for one side to have Checkpoint, the other side to have Juniper, and you don't necessarily replace all your firewalls, and you still have to deal with those interconnects. And of course, every time you add a new site, you have to add the site to the full mesh. So you have to establish tunnels between this new location and all these other different locations and deal with all the different routes that need to be taken into consideration in order to ensure sites do not remain disconnected. So let's take a look. What does that mean in Cato? Okay, so we have a new site in London. I'm going to show it to you in a minute. We send a socket to this site, and we want to plug it in and establish or connect that site to the mesh. Okay, so let's take a look. So let's go and add a site. So we're adding a new site. I'm going to type the name, London site. This is a branch. We're using a Cato socket here. Selecting the country. Password. And we're defining the IP range for that site. So which IP addresses are reachable behind that site. Now what we have here is that the Cato socket in the site has reached out to the Cato cloud. We're now going to accept that socket into the customer network and associate it with the site that we just defined, the London site. So now the London site is plugged into the Cato cloud. And we are now going to connect it to the mesh. Okay, so I go to the security definitions, the WAN firewall, specify a new rule, which connect the London site to our data center, our headquarters, and we're done. This is it. This is what it takes to add a new site and define the wide area network policy for that site. And compare that with the need to establish point-to-point tunnels between that site and every asset that we have in the company. So let's move on to the third scenario. Now we have a mobile user that would like to have a VPN access to headquarters in order to access a data center resource, and at the same time want to access the cloud. But in that case, if they go directly to the cloud, there is no network security stacks for the company between them and the cloud. So there is no control of that access. So what do we do here? Let's take a look. We're activating the Cato client. We connect to the network. You can see here on the right side Now we have the user showing up in our UI, and we can now go and define the rules to enable that user to access the resources they need. So the first rule will be the wide area network resource. So in this case, we are connecting the user to the headquarters, the data center, and to Amazon AWS, which are all IP ranges. At the same time, we enforce a policy. I'm going to do that with the Internet Firewall that blocks access to an application, in this case, Dropbox. Okay, so let me do that. Selecting the user, selecting the application, and now you can see what happens on the left side when the user tries to go to Dropbox. Okay, we'll take a look at that. Okay, so the user goes to Google, goes to Dropbox, and they are basically denied. Okay, so this is basically how you enable in one place to connect the user through our Cato client to both data center resources, on-premise resources, as well as control their access to the cloud. Okay, so we covered those scenarios. I want to talk about how you deploy this solution. And I mentioned earlier that there is an opportunity here for a phased deployment. So let's take a look at that. 4 simple steps. How do we go from a legacy network to a Cato-based network? The first thing we typically do with customers is we choose sites, could be a couple sites. You can see here one site is protected by a firewall, one site, one branch is not. If there is a firewall in a site, we can define an IPsec tunnel and send only the internet-bound traffic to Cato. We do the same thing with the Cato socket. We can split the internet traffic at that site, send it to the socket, and from there it's going to get to the Cato cloud. Okay, so the customer at that point is typically testing our direct internet access scenario. Okay, they enforce security on those traffic. The second step is to connect the data center with typically an IPsec tunnel from the firewall in the data center to the Cato cloud. We're doing it in preparation of taking over the wide area network traffic in addition to the internet traffic. So in step 3, that's what we do. We eliminate the firewall in the remote branch, put a socket in, and send all the traffic to the Cato cloud, both wide area network traffic and internet traffic. And through the Cato cloud, that traffic reaches the data center in the middle. On the right side, we now move both wide area network traffic and the internet traffic through the Cato socket to the Cato cloud. What we can do here optionally is eliminate the MPLS link and simply rely on the internet connectivity, or we can continue to use MPLS for specific subset of the traffic and send the other subset through the Cato socket. So again, you can take internet traffic, you can take a subset of your WAN application and send it to Cato, and keep on the MPLS just another subset. The fourth step is to add the cloud and mobile elements of our network to the Cato cloud. So what you're seeing here is we're using the vSockets and the clients, and we just plug in to the Cato cloud, and all the work we had done before enables essentially seamless integration. So those cloud infrastructures can be accessible by branches, by the headquarters. The mobile users can now access data center resources and cloud resources. Essentially, all of these things can now operate in concert. And you can do this as quickly or as slowly as you want, and the different elements of the network of legacy and the next generation network, both of them will work in harmony. Before I conclude, a couple more slides, I want to explain or demonstrate to you how convergence makes a difference for IT. So you now look at just one of these architectural diagrams I used. This is our full platform. Now, when you go into the marketplace, what you're going to be seeing is a bunch of point solutions that are covering this element that I described today. For example, when you look at our security stack, companies like Zscaler or cloud-based secure web gateways provide that functionality. If you want to get global area network with SLA backed latency, you would go to companies like Ariaka or companies that provide MPLS services. In order to secure your branches or your headquarters, you use physical firewalls. We can replace them. SD-WAN solutions tackle the individual problem of the cost of MPLS. So they're trying to get internet into the mix, but they don't do anything else of everything that is listed here. CASB product, cloud access security brokers, trying to address security for cloud data centers and cloud applications. That's yet another point solution that we address with our vSocket and Cato clients. And finally, our cloud-based management provides a single console to manage all these 5 domains in a single interface. So when you look at Cato, it's not just the individual challenge that you have today that you're trying to tackle. There is a very big leverage here for every dollar that you spend on a platform that can encompass so many domains, so many individual products and capabilities under a single umbrella. And this is something I really want you to take with you as you look, as you compare, as you consider. Try to think about how you can leverage this platform to tackle not only the challenge of the day, not only the specific problem that you have on the table today, but really more holistically, as you can see here in the chart. So to summarize, we are trying to help you have your cake and eat it too. So no appliances. We are going to enable you to eliminate branch office appliances and improve your security posture with enterprise-grade cloud-based network security. You can eliminate backhaul, so you can directly send internet traffic from the branch without backhauling into a data center or a regional hub. And you get an SLA-backed WAN backbone. So if you want to plan a gradual migration off your MPLS, this is a platform that stands a chance to do that. If you use the open internet, it's going to be very difficult to ensure service levels for latency-sensitive applications like voice. And finally, we expand the notion of the wide area network for everyone and everywhere. So it's not just about your physical locations, it's also about your mobile users, about your cloud infrastructure, and without piling up more and more point solutions to address those needs. If I summarize, what Cato provides is network plus security for the way business gets done today. Thank you very much for your listening. We will now open us for some questions from the audience.
I have one more poll question, and that is, would you like to have a personal demo with one of our network security experts? You can start answering now.
Okay, so let's see if we have questions coming in as we wait for that. First question, can I run voice over IP traffic on your global network? What about latency? So as we look at this, we looked at some guidelines, best practices on voice over IP. You basically need 300 millisecond round trip time. That's the maximum for good quality calls. You want to have less than 1% packet loss, and the jitter should be no more than 50 milliseconds. And we basically provide this SLA over our global backbone, and that's something you can definitely do with Cato, and you're going to be challenged to do with public internet-based connectivity. Question, can I migrate only part of my locations to your cloud? As I mentioned, yes. The answer is yes. We can definitely mix and match. If you think about a retail operation, you can take a bunch of stores, connect them to Cato, get very good security, very good connectivity, but keep your data centers and major locations intact, running on your existing MPLS network, for example. Third question, what is the difference between Cato and Zscaler? So I mentioned, I've shown a slide where you can see all the different kind of how much broader the coverage of Cato is versus Zscaler. Specifically, I would talk about their firewall capability. They only provide internet-based firewalls, so they can only secure the traffic going to the internet. Cato provides both a wide area network security solution as well as internet security solution. So we are in fact able to replace firewalls that are part of a mesh where Zscaler cannot replace those firewalls. Next question. What kind of resiliency is built into your cloud? It's actually a very good question. So the cloud is very, very redundant. Every POP runs multiple instances, physical servers of our infrastructure. Of course, all these POPs, all these servers back up one another. We have inter-POP redundancy. So if a full POP is unavailable, traffic fail over to the nearest physical POP, typically within the same region. If there is a full outage, we have an extreme form of redundancy that allows sockets to establish inter-site connectivity. So right now, I've shown the example of the global manufacturer. This is a 5.9 network. If the SAP instance in Germany is not reachable, the business is severely impacted. We've been running for 5 months. We are providing the service level that they're expecting. Few more questions. Is SSL on Cato? The answer is yes. We are opening up SSL using the typical tactic used with physical firewalls, and we can inspect the SSL for malware, for example. Which OSs does the Cato client support? For Windows, Mac OS, iOS on iPhone, and Android. You can find the app stores, the different app stores, our mobile clients. The clients are part of the solution when you license our product. This is all included. Maybe I'll mention that. When you license our product, both the Cato sockets and the Cato mobile clients are included in the service, so we do not charge for them separately. Next, does Cato integrate with Active Directory? The answer is yes. We integrate with Active Directory and we use it to populate users, groups, etc. In our database. Do you have NAT capability for branch offices using the same private ISP space? We are basically the typical network design that we work with is that there are unique IP ranges. This is a requirement that came up in recent pilots, adding it to our solution. With the Cato Cloud, you provide SaaS acceleration. What applications? So right now, the acceleration we provide is generic. So most of it is through protocol optimization and optimized path selection. So this is generic optimizations. We plan to roll out additional capability in 2017. What I can say is that a lot of the optimizations that are associated with Office 365. For example, using ExpressRoute for Azure. These are things that you get with Cato kind of built in because our POPs are in very close proximity to the Microsoft Azure and Office 365 backbone. So one of the challenges, again, for wider network connectivity is latency, and we're addressing that directly by being essentially closely aligned, same data centers as the Microsoft infrastructure. So I think these are the questions that we have time to address today. I'd like to thank you for attending, and we will provide the slides as part of a recording that will be released in the next few days. Thank you very much, and Bonnie, back to you.
All right, everybody, thank you for your time. We appreciate you being here and the feedback that you've given us. Have a great day.